Today's lesson is on solving equations. This is chapter 2. Before we begin the lesson, you will need to print the PowerPoint slides. All the notes that you see written on slides should also be written on your paper. Let's begin. Solving one-step equations. Before we can talk about how to solve a one-step equations, we need to get some of our terminology discussed. Our first definition is value. Value is the solution of an equation. So for example, if you had x equals 2, the value of x would be 2. Equivalent equations are equations with the same solution. Inverse operations are operations that undo each other. For example, to undo addition, you would need to subtract. To undo multiplication, you would need to divide.
Okay, we just learned the terminology, so now we are going to apply the terminology. R plus 16 equals negative 7. This is a one-step equation. Our goal is to get the variable, r in this case, by itself. So we have plus 16 that we need to get rid of. So we want to do the opposite and minus 16 so that it will equal 0. What we do to one side of the equation, we must do to the other. That is a rule in solving equations so that your equations stay equal. So this will give us r equals negative 23 because we do negative 7 minus 16. Now, to see if you are correct, you can substitute negative 23 in back for r. So negative 23 plus 16 equals negative 7. So does negative 23 plus 16 equal negative 7? Yes, it does. So therefore, my left equals the right side, and I have done the equation correct. That is just a way to check yourself to know if you're doing it correctly. Okay, let's move on to the second equation. U minus 23 equals 21. In this case, we are solving for u. That is our variable. We have minus 23 this time, so we're going to do the opposite and plus 23. What we do to one side, of course, we have to do to the other. That's important to remember. So in this case, u equals, this will be gone because that will equal 0, and this is 44. Now to check it, go ahead and substitute 44 back in for u, and so we do 44 minus 23 equals 21. And so 44 minus 23, yes, that equals 21. And so therefore we know we did it correct.
Now that we've talked about how to add and subtract one-step equations, let's talk about how to multiply and divide one-step equations. As discussed before, our goal is always to isolate the variable, meaning get it all by itself on one side of the equal sign. In our first example, we have 5h equals negative 35. Right now, 5 is multiplying h. Therefore, we need to undo the multiplication. The opposite of multiplying by 5 is dividing by 5. So we're going to divide both sides of the equation by 5. Our 5's on the left side cancel out, and we are left with h equals negative 7. To test our work, we would say 5 times negative 7 equals negative 35. 5 times negative 7 is negative 35. Therefore, both sides of our equation are equal, and our work has been done correctly. On our second example, we have x divided by 121 equals 3. Right now, x is being divided by 121. Therefore, to undo the division, we need to multiply both sides by 121. $121 cancels out on the left side, and you're left with only x. 3 times 121 is 363. To test our work, we would say 363 divided by 121 equals 3. 363 divided by 121 is 3, and 3 does equal 3, so our equation is balanced, and therefore it checks out. Here are two more examples of one-step multiplication problems. Our first example, 18 equals 6n. If our goal is to get n by itself, and right now n is being multiplied by 6, we need to divide both sides of the equation by 6. Our 6's on the right cancel out. N is the only thing left. 18 divided by 6 gives us 3. And therefore, we need to plug 3 back in the equation to check out. So we would say 18 equals 6 times 3. Well, 6 times 3 is 18. Therefore, both sides of our equation have balanced and our work is correct. On the second example, we have negative 5t equals 25. To get t all by itself, we need to divide both sides by negative 5. Our negative 5's cancel out, and we're left with t equals, and 25 divided by negative 5 is negative 5. We've got to plug this back in to make sure our math is correct. Negative 5 times negative 5 equals 25. Well, that's true. Negative 5 times negative 5 is positive 25, and therefore both sides of our equation are balanced, and our work checks out. Let's do some additional practice on one-step equations when we're dividing. Right now our problem says x over 4 equals negative 12. To do the inverse of dividing by 4, we need to multiply by 4 on both sides of the equation. Our 4's cancel on the left side, leaving us with x. And then we have negative 12 times 4, which gives us negative 48. To test our work, we plug this back in. Negative 48 over 4 equals negative 12. Negative 48 divided by 4 is negative 12. Therefore, our equation is balanced and our work checks out. On our second example, we have 2/3 x equals 8. In order for us to get rid of a fraction, 2/3, we need to flip the fraction and multiply. Remember, whatever we multiply on one side, we must multiply on the other. If we're flipping the fraction, we now have 3 over 2. Two over 3 and 3 over 2, when they're multiplied together, cancel to a 1. 1 times x leaves us with just x. 8 times 3 over 2 gives us 12. To test our work, we would say 2/3 times 12 equals 8. Well, 2/3 times 12 is 8, and 8 equals 8. Therefore, our work is correct. Sometimes students are intimidated when they see fractions or decimals. However, one-step equations with fractions and decimals should not scare you. Same process as when we add or subtract any other number. In our first example, we have 7.3 plus s equals 5.2. We're still trying to get s by itself. For me to move a positive 7.3 to the other side of the equal sign, I have to do the opposite. Well, the opposite of a positive is a negative, so we have to subtract 7.3 from both sides. Cancels out on the left side, and we're left with s equals, and then we have 5.2 minus 7.3, which gives us a negative 2.1. To test the work, you just plug it back in. 7.3 plus negative 2.1 equals 5.2. 7.3 plus negative 2.1 can be rewritten as 7.3 minus 2.1, which equals 5.2. 5.2 equals 5.2, and our work checks. The second equation didn't come out very clearly the way I intended it. It should say b minus 3/4 equals negative 1/4. The lines kind of ran together there. Sorry about that. So we have a b that we need to get all by itself, and we have a negative 3/4. To get rid of a negative, I need to add 3/4 to both sides. The left side cancels out. We're left with b equals, and in your calculator, if you do negative 1/4 plus 3/4, you will get a positive 1/2. To test your work, plug it back in. 1/2 minus 3/4 equals negative 1/4. When you do the math, you have negative 1/4 equals negative 1/4. Therefore, you're balanced and your check work is correct. Here's another example of a one-step equation that's written a little differently. Here, you've got the shape of a triangle, and they gave you the lengths of two sides of the triangle. We know that these lengths are equal because of these little bars that you have on the sides of the triangle. Therefore, what that means is that we can set those lengths equal to each other. One of the sides' lengths is 30 yards. The other side is n plus 13 yards. Well, now we need to solve for n, and we have a one-step equation. In order to solve this problem, we need to do the opposite of adding 13. So we'll subtract 13 from both sides. 13 cancels out on the right side. We're left with n. 30 minus 13 equals 17. However, your final answer should always be written with the variable first. So your final answer should be n equals 17, and we need to keep our unit of measurements, so we rewrite yards. Now that you're in algebra class, we need to really focus on eliminating our double signs and simplifying our equations. What we mean is, in the first example, you have y plus negative 3 equals 8. Well, as a general rule, whenever you have plus a negative, you simply replace that with a minus sign. So we would rewrite that, y minus 3 equals 8. If we solve that, we would add 3 to both sides, and you would get y equals 11. Okay, and our second example, we have a double negative, p minus negative 5. Well, it's a lot easier to just rewrite that problem as p plus 5. To solve for p, we would subtract 5 from both sides. You would be left with p equals 1. Okay, so just remember the note at the bottom. As a general rule, you're going to replace plus negative with just a minus sign and replace a minus negative with a plus sign. It's going to make things a lot less confusing the further along you get in algebra. All right, so let's take a moment here first to simplify our equation. Use the information we discussed on the previous slide. We have x minus negative 2 equals 1. So the first thing we want to do is get rid of that double sign. So we're going to rewrite the problem, negative x plus 2 equals 1. From here, we've got to solve for x. Well, first thing we've got to do is get rid of the 2. So we're going to subtract 2 from both sides. 2's here cancel. We're left with negative x equals, and then 1 minus 2 gives us negative 1. Now here comes the second step in our equation. We are never allowed to leave our variable as a negative. So what we must do is divide by negative 1, because currently x is being multiplied by negative 1. To undo multiplication by negative 1, you divide by negative 1. Our negatives cancel. We're left with x equals, and negative 1 divided by negative 1 is positive 1. To test our answer, we plug it back into the original equation, and we're going to use our simplified equation as our original. So we'll say negative, and then 1 goes in for x, plus 2 equals 1. Well, negative 1 plus 2 is 1, and 1 does equal 1, so it checks out. Our second example, you've got 2y plus negative 3. So we need to simplify the double sign and simply rewrite this as 2y minus 3 equals 7. Well, now that we have 2y minus 3 equals 7, we've got to get rid of the minus 3. To get rid of that, add 3 to both sides. Our 3's cancel on the left, leaving us with 2y equals 10. Divide both sides by 2. And you are left with y equals 5. Plug that in to our simplified equation, and you would say 2 times 5 minus 3 equals 7. Well, 2 times 5 is 10. 10 minus 3 is 7. Our work checks out. All right, so we're going to do a couple more examples of two-step equations. Remember, our goal is always to get the variable by itself. We're never allowed to touch the term with the variable until the very end. So the first thing we need to do is subtract 2 from both sides. Our 2's cancel on the left, leaving us with 6x. Then you've got 8 minus 2, which gives us 6. And in order to get x all by itself, we have to undo the multiplication. The opposite of multiplying by 6 is dividing by 6. Divide both sides by 6. And left over is x equals 1. So to test this, you would say 6 times 1 plus 2 equals 8. 6 times 1 is 6. 6 plus 2 is 8. 8 does equal 8. So our work is correct. On the second example, you have 10 equals m over 4 minus 2. Again, if our goal is to isolate the variable, we are not allowed to touch the term that includes the variable until the very end. So first thing we need to do is add 2 to both sides. Our 2's cancel on the right. 10 plus 2 gives us 12. And we are left with m over 4 on the right side. Currently, m is being divided by 4. The opposite of dividing by 4 would be to multiply by 4. So we need to do that to both sides. Our multiply and divided by 4 cancels, leaving us with simply m. And then we have 4 times 12, which gives us 48. Okay, again, remember, you need to write your variable first in your final answer. So this should be m equals 48. And now we need to check our work. So we say 10 equals 48 divided by 4 minus 2. "48 divided by 4 gives us 12. 12 minus 2 gives us 10. And 10 does equal 10. Therefore, our work is correct. Our next example looks more complicated than it truly is. Remember, when we have a matrix, we need to look at the different places within the matrix. So first of all, we're comparing what's on the top left with what's on the top left. And if you notice, we are not adding, subtracting, multiplying, or dividing these matrices. They are set equal to one another. Therefore, we can solve these by saying 2a plus 1 equals 11. To solve that, we simply subtract 1 from both sides, leaving us with 2a equals 10. Divide both sides by 2, and you are left with a equals 5. And we would put that in the same place in our matrix at the bottom. So you would have a equals 5 on our top left. Again, you would go through the same process with each one. So you would say, if we were going to look at our blue values, -6 equals x minus 5. So let's do that up top. -6 equals x minus 5. So we need to add 5 to both sides. When you add 5 to both sides, -6 plus 5 gives us x equals -1. And that goes in the top right. Looking at our green values, you have -7 equals 5 minus 2y. Okay, we need to subtract 5 from both sides. -7 minus 5 gives us -12. Equals 2y. And that's a -2y because we have to keep the sign that's in front of the term. So that's a -2y. And then -12 divided by -2 gives us a +6. So we would have y equals 6 in our bottom left. And our last one, we've got -3k equals 27. Divide both sides by -3, and you're left with k equals -9. And again, we're just going to fill that in our answer matrix. So k equals -9. Now let's do an example of a real world problem. Okay, let's say you are ordering tulip bulbs from a flower catalog. You have $14 to spend. Each bulb costs 75 cents plus $3 shipping. How many bulbs can you buy? Okay, so let's take some of the information. We know that we are going to have a limit of $14. We just cannot spend any more than $14 because we don't have any friends to borrow from. We don't have any additional income coming in here. It's telling us that we have a maximum of $14. Okay, so that's going to be on one side. And each bulb cost 75 cents plus $3 shipping. Well, it didn't tell us how many bulbs we're actually buying. That's what it's asking us to find, is how many bulbs. Each, if you remember back to our previous chapter, stands for multiplication. So we are saying 75 cents times the number of bulbs plus $3 shipping is going to equal our maximum of $14. Therefore, we've got to subtract $3 shipping from both sides. And we're left with 75 cents per bulb equals $11. To find out the number of bulbs, I have to divide by 0.75. 11 divided by 0.75 gives us 14.66 repeating bulbs. Well, if you think about this, can I buy a fraction of a bulb? Certainly not. They're not going to tear apart a perfectly good bulb to send you one in the mail. So the most bulbs that we can actually buy is 14. Remember, in any word problem, you need to make sure you're documenting what your unit of measure is. In this case, it's bulbs. Now our equations are getting a little bit more complicated. They're getting a little longer, and if you notice, in these two examples, we have variables on both sides of our equations. Well, in order to solve this equation, you must get your variables on the same side. As a general rule, it's always easier to move whichever variable is going to give you a positive answer. So I'm going to subtract 2x from both sides. 3x minus 2x gives me a positive 1x. I didn't use plus 2, so that's going to stay. My 2x's cancel it on the other side, leaving me with negative 1. From here, to solve for x, I subtract 2 from both sides. My 2's cancel on the left, leaving me with x equals negative 3. I have to test my work, and I'm going to plug it into the original equation. So I say 3 times negative 3 plus 2 equals 2 times negative 3 minus 1. 3 times negative 3 gives me negative 9 plus 2. And 2 times negative 3 is negative 6 minus 1. And I'm left with negative 7 equals negative 7, which is true. So let's go to our second example. Which would be easier to move? The 8y or the negative 3y? If you said negative 3y, you would be correct. So we're going to add 3y to both sides. That gives us 11y minus 9 equals 2, because our 3's canceled. I need to add 9 to both sides. My 9's cancel, leaving me 11y equals 11. Divide by 11. I'm left with y equals 1. I do need to test my work. 8 times 1 minus 9 equals negative 3 times 1 plus 2. So I'm left with 8 minus 9 gives me negative 1. 3 times 1, negative 3 times 1 gives me negative 3 plus 2 also gives me negative 1. My work is correct. Now we're going to move on to multi-step equations. Multi-step equations just mean that the problems are a little bit longer, and obviously you're going to have a few more steps that you need to complete before you can solve for your variable. The first thing you always want to think about is, do I have anything to distribute? Well, in our first example, we do. We need to distribute a negative 7 to everything inside of the parentheses. So we get negative 7x. Negative 7 times negative 3 gives us a positive 21 plus 15 equals negative 7. The second thing you need to think about is, do I have any like terms on the same side of the equal sign that need to be combined? In this case, we do. We have a positive 21 and a positive 15. 21 plus 15 give us 36. So I have negative 7x plus 36 equals negative 7. Okay, I don't have variables on different sides of the equal sign, so I'm okay to continue on to undoing the addition. So I'm going to subtract 36 from both sides. I'm left with negative 7x equals negative 43. In order to complete this problem, I need to divide both sides by negative 7. And I am left with x equals positive 43 over 7 because our negatives canceled out. Now, you are allowed to have a variable that is a fraction. So we have 43 over 7. But to make sure that that is the correct fraction, again, we need to plug that in. So you have negative 7 times 43 over 7 minus 3 plus 15 equals negative 7. Okay? Negative 7 divided by 7 cancels out, leaving us with negative 43. Negative 7 times negative 3 gave us positive 21 plus 15 equals negative 7. And then we're left with negative 43 plus 36 And negative 43 plus 36 does give us negative 7, which equals negative 7. So our fraction was correct. All right, so let's look at our second example. In our second example, we do not have anything to distribute, so we can move on to the second step. Do we have any like terms on the same side of the equal sign that can be combined? In this case, we do. We have a 2c and a 1c. 2c's plus 1c give us 3c plus 12 equals 78. We need to subtract 12 from both sides. When we subtract 12 from both sides, we are left with 3c equals 66. Divide both sides by 3. You're left with c equals 22. To test that work, again, you simply plug it back into the original equation. 2 times 22 plus 22 plus 12 equals 78. Two times 22 gives us 44. 44 plus 22 gives us 66. 66 plus 12 gives us 78, which does equal 78. Good job. Let's continue on discussing multi-step equations. Our first example probably looks a little intimidating because of all the fractions. However, you are still going to go through the same process in solving a problem with fractions as we have already discussed. First thing to think about is, do we have anything to distribute? In this case, no. So our second thing to think about is, do we have anything to combine on the same side of the equal sign? Well, we don't have any like terms on the same side of the equal sign, so we're moving on. Are all of our like variables on the same side of the equal sign? Now we've got something to do. Our like variables are on opposite sides of the equal sign. Therefore, we need to go ahead and get those on the same side. The easiest way to get these on the same side would be to add 1/4 x to both sides. Leaving us with 3/8 equals 1/2 x plus 1/4 x gives us 3/4 x minus 3/4. Again, we can't do anything with the term with the variable until the very end. So we need to undo the subtraction. To do that, we're going to add 3/4 to both sides. Three eighths plus 3/4 give us 9 over 8, which is equal to 3/4 x. All right, so now we come to a situation that we've got a fraction multiplying our variable. Well, we can't divide by a fraction because dividing by something that's already being divided is complicated. If you remember your rules for your fractions, in order to do the inverse of dividing by a fraction, you need to multiply by the reciprocal, meaning that we've got to flip the fraction. So before, the 4 was on the bottom and the 3 was on the top. Now we're moving the 4 to the top and the 3 to the bottom, and now we're ready to just multiply. So our fractions cancel, leaving us with just our x. And then 4/3 times 9/8 give us 3/2. To test the work, you would say 3/8 minus 1/4 times 3/2 is equal to 1/2 times 3/2 minus 3/4. When you plug all of those fractions in, you're going to get that 0 equals 0, which does check out. Okay, I know that's a lot of work crammed into a little bit of space, and I do apologize for that. Try to make sure that your notes are a little bit more tidy than mine. Let's look at our second example. Right away, you should be thinking, I definitely have something to distribute because we have parentheses with a number outside. So let's distribute our 3, leaving us with 3x plus 12 equals, well, it looks like we have something to distribute on the other side as well. So let's distribute our 2. So we have 2x minus 2. All right, so we've completed step 1. We've distributed. Second thing to think about, do we have anything to combine on the same side of the equal sign? In this case, no. So move on to step 3. Are all of the like variables on the same side of the equal sign? No, they're not. So we need to move one of our variables. It's easiest to move the 2x, because subtracting 2x from both sides will still give us a positive variable. So we are left with x plus 12 equals -2. And to finish solving for x, we need to subtract 12 from both sides. Leaving us with x equals -14. To test your work, we plug -14 back in everywhere we see x. So 3 times -14 plus 4 equals 2 times -14 minus 1. Negative 14 plus 4 gives us 3 times negative 10. And negative 14 minus 1 gives us 2 times negative 15. From there you do the math on both sides. 3 times negative 10 is negative 30. 2 times negative 15 is also negative 30. And our work is correct. All right, let's go ahead and get another word problem under our belt. Remember, again, the first thing that you should always do when completing a word problem is read the problem all the way through so you can figure out exactly what's going on and what they're asking you to figure out. Heidi's cell phone plan is $60 per month plus 10 cents per minute over her 500-minute call time allowance. If Heidi's cell phone bill was $92, how many minutes were billed over the 500-minute allowance? Okay, so we know what her bill was, and we're trying to figure out how many minutes was she billed over her 500-minute allowance. Well, if we know that her bill equals $92, we got to figure out what else about the problem. Well, we know that she has to spend $60 a month. It's just what her plan cost. Plus an additional 10 cents per minute. Remember, per means multiply. So we're multiplying 10 cents per however many minutes she talks. So now we've got an equation where we've got to solve for the number of minutes. Subtract 60 from both sides. We're left with 10 cents per minute equals 32. Divide both sides by 0.10. And you will see that Heidi talked 320 minutes over her 500-minute call allowance. You are planning a rectangular garden. The garden is next to an existing 12-foot fence. You have 44 feet of fencing to build the other 3 sides. How long will the garden be if the width is 12? All right, so in these type of word problems, it's usually easiest to figure them out with a visual. So let's draw a picture of what's going on. We have an existing fence that's 12 feet. And we need to make a rectangular garden, correct? Well, we already said it was going to be 12 feet wide based on the information in the problem. We have 44 feet of fencing. Well, do we know how long it's going to be? Absolutely not. That's what it's asking us to find in the question. But we do know that both of those sides add up to the 44 feet of fencing. Okay, so now let's do what our perimeter formula tells us to do. Add all the sides. Well, we cannot count the existing 12 feet of fencing because that's already there. That's not something that we're actually going to have to account for in our problem. So if we say L plus 2, we get 2L plus 12 equals 44. So our two lengths plus the 12 feet that it's going to be in width is going to equal our total amount of fencing that we have of 44 feet. So let's solve for the variable. Subtract 12 from both sides. You're left with 2L equals 32. Divide both sides by 2. And you get that your length equals 16. Okay, to test your work, you would say 2 times 16 plus 12 equals 44. And it does. 32 plus 12 equals 44. All right, so let's talk about some special situations that you might come across when doing your math. We're going to solve these equations just like we've been doing in every other problem. Okay, so we don't have anything to distribute. We don't have any like terms to combine on the same side of the equal sign. But we do have variables on opposite sides, so we need to get them on the same side of the equal sign. Doesn't matter which 12 we subtract, but we've got to get our 12x's on the same side. Well, 12x minus 12x cancels out to 0, leaving us with -3. But if you look on the other side, we also have 12x minus 12x, which cancels to a 0, leaving us with -3. This is what we call an identity, okay? And you have to write identity under it. What an identity equation means is that any number you put in for the variable, both sides of your equation will be the same. Okay, so let's prove that. Pick any number you want. Take a minute, pause the slide, plug it in for your variable, and see if you get the same number on each side of the equation. If you do, you've done your math correctly. Let's look at our second example. All right, so first thing to think about, do I have anything to distribute? Yes, so let's go ahead and do that. So we've got 3x plus 3 minus 5 equals 3x minus 2. Second thing to consider is, do we have any like terms to combine on the same side of the equal sign? Yes, we do. We need to combine 3 and -5. So 3 minus 5 give us 3x minus 2 equals 3x minus 2. Okay, I need to get my variables on the same side of the equal sign. So we need to subtract 3x from both sides. And we are left with -2 equals -2. So again, there's another example of identity, and you need to make sure you write the word identity under -2 equals -2. Another special case is when sometimes you solve the equation and there is no solution. So let's talk about that. Got to get my variables on the same side, so I subtract 2x from both sides. My 2x's cancel on both sides of the equal sign, and I'm left with 5 equals -3. That is not true. They are not equal. Therefore, this is a no solution. Again, no solution has to be written under your final answer. What no solution means is that there is no number that you could plug in for x and make both sides of the equation balance. There's just not a number. There's not a solution. Okay? Let's look at the second example. You have 6m minus 5 equals 7m plus 7 minus m. Well, nothing to distribute, and I have no like terms to combine on the left side, but I do have like terms that I can combine on the right side. So I'm left with 6m minus 5 equals 7 minus 1 gives us 6m plus 7. All right, got to get my variables on the same side of the equal sign. So we'll subtract 6m from both sides. My 6m's cancel, leaving me with -5 equals 7. Those two numbers are not equal, and therefore you need to write no solution under your final answer. Here are two examples of fractions that are written a little bit differently than what you might be used to seeing. In our first example, d minus 4 over 2 equals 3. Well, we know that d minus 4, the whole thing is being divided by 2. Therefore, we have to undo the division by multiplying the whole thing by 2. Whatever we do to one side, we must do to the other side. Multiplying by 2 and dividing by 2 cancels out. We are left with whatever's on the top, which is d minus 4. Add 4 to both sides. And we find that d equals 10. Again, to check your work, you would say 10 minus 4 divided by 2 equals 3. 10 minus 4 is 6. 6 divided by 2 is 3, and our work is correct. So let's try the second example. d plus 1 all over 3 equals -6. So I have to multiply both sides by 3. My 3's cancel. I'm left with d plus 1 equals negative 18. Subtract 1 from each side, and you get D equals negative 19. Check your work. Negative 19 plus 1 divided by 3. Negative 19 plus 1 gives you negative 18. Negative 18 divided by 3 gives you negative 6, which does equal negative 6. And your work checks out. All right, so we've got a couple of word problems that we're going to do over the next few slides, just to show how you can set equations up when given a word problem. Okay, again, first thing to do, read it all the way through. A video store charges non-members $4 per movie rental. A store membership costs $21 and members only pay $2.50 per movie rental. For what number of videos is the cost the same? So we are comparing members and non-members. So on one side we have non-members. On the other side we have members. Well, our non-members are charged $4 per movie, per meaning multiply. Okay, so $4 per movie. We're trying to find where our non-members and our members are the same, so we need to set them equal. Well, members have to pay a membership fee of $21, and they're still charged $2.50 per movie. So now we've got to solve for M. Subtract 250 M from both sides. You're left with $150M equals 21. Divide both sides by 150. And you're left with M equals 14 movies. Okay, remember you've got to write movies because this is a word problem. We've got to say what M represents. So if you are going to rent a movie every week, it would be beneficial for you to become a member because you're going to spend money 52 weeks out of the year on a movie, which is a lot higher than 14 movies. But if you only rent maybe 5 movies a year, becoming a member would not be cost effective in that situation. Our second word problem is, again, another geometric shape. We've got the length of a rectangle is 4 inches greater than the width. The perimeter of the rectangle is 24 inches, and they want you to find the dimensions of the rectangle. Anytime you're given a shape, it's easiest to draw the shape so you can get a visual. Well, we don't know what our width is, correct? Didn't tell us in the problem. So we're just going to represent our width with W. But we do know that our length equals 4 inches more than the width. So it's W plus 4. Okay. At this point, all we need to do is add up how many W's we have. And we've got 4W plus 8, because I've got 4 plus 4, equals 24. Subtract 8 from both sides, and you've got 4W equals 16. Divide both sides by 4, and you're left with W equals 4. So if our width equals 4 inches, then our length has to equal 4 plus 4, which is 8 inches. Remember, it wanted the dimensions, meaning it wants the length and the width. A passenger train's speed is 60 miles per hour, and a freight train speed is 40 miles per hour. The passenger train travels the same distance in 1.5 hours less time than the freight train. How long does it take each train to make the trip? All right, so again, we are comparing a passenger train and a freight train. We're trying to see where these two trains will be equal. Well, our passenger train travels at a rate of 60 miles per hour. But we know that its amount of time is 1.5 hours less than the amount of time of the freight train. And the freight train travels at 40 miles per hour. Okay, so 40 times the amount of time will be the freight train speed, and then the passenger train is 60 times t minus 1.5 hours. So let's distribute. 60t minus 90 equals 40t. Now I cannot subtract 40t because that would give me a 0 on that side of the equal sign, which is not possible. So unfortunately, we're going to have to deal with the negative number and subtract 60t. So I've got negative 90 equals negative 20t. I need to divide both sides by 20, and let me give myself some room up here. So let's rewrite. Negative 90 equals negative 20t. Divide both sides by negative 20. And you get, and I'm just going to flip-flop it in advance, t equals 4.5 hours. Okay? To test this, you're plugging 4.5 hours into the original equation. Okay? What I'll need to do is say 60 times 4.5 minus 1.5 equals 40 times 4.5. And once you do all the work, you should have 180 equals 180, which will check out. You want to make sure that you show that work on your own paper because I don't have enough room to show it here for you. All right, so now we're going to talk about how to find consecutive numbers. Our problem wants us to find 3 consecutive integers whose sum is 126. Now, we know that sum means to add. So we're adding three numbers to equal 126. Well, do we know what the first number is? No, we don't. Whenever we don't know something, we represent it with a variable. But we do know that to get from one number to the next, you have to add 1 to it. And to get from that first number to the third number, we have to add 2, which would give us 3x plus 3, and we're going to plug that into our equation. From here, subtract 3, you get 3x equals 123. Divide by 3, and you're left with x equals 41. So now let's try this out. If we said 41 was our first number, and we added 42, because that should be our second consecutive number, and then we added 43, would that equal 126? Yes, it does. Therefore, our work is correct. Remember that consecutive means in a row. So if somebody asked, how many consecutive games did our team win? Or how many consecutive championships did a team win? Consecutive means in a row, one after another. So if consecutive means in a row, and we're looking for the sum of 4 consecutive odd integers, and we want the odd integers that add up to 216. Well, let's just talk about what are consecutive odd integers. Well, 1, 3, 5, and 7. Those are all consecutive odd integers. Well, if 1 is the number I started with, and remember, we don't really know which number we're starting with, so we're representing it with x. How did I get from 1 to 3? Well, I said x plus 2. How did I get from 1 to 5? I added 4. And to get from 1 to 7, I add 6. So I just used the numbers here to help me figure out what my formula should be over here. So I have 4x plus 12. And I'm going to plug that in. And I say 4x, excuse me. That should be 4x plus 12 equals 216. Subtract 12 from both sides. And you're left with 4x equals 204. Divide by 4. And you get that x equals 51. Well, it's asking us to find the 4 integers. Well, we found the first one. So our first one should be 51. The second odd integer would be 53. Then 55. and 57. To test those, make sure they're correct, add those four together and see if they equal 216. Okay, we're going to discuss the last topic in Chapter 2, which is solving formulas. Solving formulas is exactly the same as solving equations. However, you don't have as many numbers and you have multiple variables. Therefore, we're going to use the same steps in solving our formulas as we did when solving our equations. In the example below, area equals 1/2 base times height. This is a real-life literal equation, and this is for finding the area of a triangle. In order to find the area of the triangle, we would simply multiply 1/2 times the base times height. However, our example wants us to solve for the height. So I need to solve my formula for h. In order to solve for h, I need to multiply both sides of my equation by the reciprocal of my fraction. So I flip the fraction, so I'm multiplying both sides by 2. 1/2 and 2 cancel, so I'm left with 2a equals base times height. If I'm solving for h, I'm trying to get h all by itself. Right now, b is multiplying h. So to undo the multiplication, I have to divide both sides by b. So I'm left with h equals 2a over b. Remember, when you are distributing to terms that are separated by addition or subtraction, you are not distributing to the 1/2, the b, and the h. The b and the h are all part of one term, so you are not distributing to those. That's how we just got the bh here. Okay, so we've got about 8 examples left to do in solving formulas, and then we're done. However, we're going to have to work hard for these last couple of slides, okay? Whenever you see a semicolon, this means to solve for. So you might want to write that on your paper so you remember what that means. This is not an extension of the problem. It means that we are trying to solve example 1 for W. So, what is preventing this term from being all by itself? Well, the 2L. So we need to subtract 2L from both sides, just as if it were a number. So, we have minus 2L plus P equals 2W. Now, I rewrote the problem in ABC order because we have to have our L before the P in ABC order. We're dividing both sides by 2 to get W by itself. Okay, so we are left with W equals negative L plus P over 2 for our first example. For the second example, we are solving for L. Right now, L is being multiplied by W and H. The opposite of multiplying by WH is to divide by WH. Whatever you do to one side, you have to do to the other. So we're left with L equals V over WH. Not that bad, huh? Third example, solving for y. So we're trying to get the term with the y all by itself. To do that, I subtract 3x I'm left with 4y equals, remember 7 is a constant, so it has to come at the end. So you rewrite it, negative 3x plus 7, and then you divide everything by 4. So you'll have y equals negative 3x plus 7 all over 4. Our fourth example, we're trying to solve for b. So I've got to get this term all by myself. I have to subtract ax from both sides. They cancel. I'm left with by equals, now a comes before c, so I have to write negative ax plus c. I'm trying to get b by itself. Y is being multiplied by b, so I have to divide everything by y. My y's cancel, and I'm left with b equals negative ax plus c all over y. Okay, so we're down to our last examples. In the first example, 3m equals 2 times the quantity 4 plus x. I'm trying to get x all by itself. Currently, everything inside of the parenthesis is being multiplied by 2. So in order to get rid of the 2, I can divide everything inside of the parenthesis by 2. Whatever I do on one side, I must do to the other. So I'm left with 3 over 2m equals 4 plus x. To get x by itself, subtract 4. So I am left with x equals 3 over 2m minus 4. The example right below, I equals PRT. This means interest equals your principal times your rate times your time. It's an actual formula. If we are trying to solve for the t, we need to divide by p and r on both sides. Our p's and our r's cancel, leaving us with t equals I over PR. In our third example, we're trying to solve for n. Currently, everything inside of our parenthesis is being multiplied by 180. Therefore, to get rid of multiplying by 180, I would divide everything by 180. That cancels, and I'm left with s over 180 equals n minus 2. I need to add 2 to both sides. So my final answer, I'm going to try to squeeze this in, should be n equals s over 180 plus 2. Circle that so you can kind of try to see it. It's all crammed in. And our last example, I am trying to solve for m. M right now is in the numerator. So the only way that I can get the numerator isolated is to get rid of my denominator. So I have to multiply both sides by h. I'm left with m plus k equals ABC order, so it's HW instead of WH. And to get m all the way by itself, I subtract k from both sides. So my final answer is m equals HW minus k. This concludes Chapter 2. We have shown you lots and lots of examples. We appreciate your patience and encourage you to continue to re-listen to this lesson if you are struggling with any portion of Chapter 2.